The session is for 2 hours. We'll have a 10-minute tea break in the middle. And as we wait for the final people to come in, let's do a round of introductions. I'm Mukund. I take care of TechNext. And I work for Synergip as an engineering manager. I do have experience in iOS and Android development.
Hello everyone, I am Ashish Moite and I have completed my BE in computers.
Hi, I am Abhijit Ashok More. I am working in Synergip Softech Private Limited.
My name is Abhishek Chikane. I am working with Cross Country Infotech. I am working in mobile projects.
Hi, I'm Gundeep Singh. I'm working with CS Holding and I'm into mobile development. Thanks.
Hey, hi, I'm Piyush. I'm working with the CS Holding and I'm into mobile technologies.
Hey, this is Nikhilesh Irisagar. I work at Soft Corner. I'm in mobile development. Currently, I'm working on PhoneGap.
Hello, I am Amar Kamte. I'm working with Soft Corner and I'm working on a mobile development project on PhoneGap and Backbone.
Hey guys, I'm Himanshu. I lead mobile development at Dhruva. And
Hello guys, Vinay Abnave here, currently working in a company Wi-Fi Soft as a developer.
Hi, I am Anish. I've been working with Amdocs for a 1 year programmer.
Hi, I'm Sandeep. I work in the storage domain, but I'm interested in mobile technologies.
Hi, I am Sachin. I am working with Infosys in HR department. I am working in the technical recruitment as well.
Hi, I'm Rishikesh. I'm working with CS Holdings as a project manager, and I work on retail domain and for mobile application development. Thank you.
Hi, I am Priyanka Varadkar, MCA final year student, University of Pune.
Hi, this is Satinder Singh from Global World Tech.
Hi, this is Asloob Qureshi. I've been working with Nitya Labs on Airstream. I've also been working with Tom, on his project for the past 6 months. Yeah, that's it.
Hi, I'm Sushma Sandbo, working in Soft Corner.
Hi, I'm Chaitra Deshpande. I'm working with Czech India Private Limited. I'm into electronics.
Hi, I'm Prahlad Deshpande. I work in information security at Symantec. Want to move into the mobile software.
Hello everyone, my name is Rishikesh. I'm working with Brain Chamber Technologies. Primarily work with the mobile application development.
Hi, I am Aditya Dado. I'm working with TCS.
Hello, I'm Sangram Zado. I'm working with mobile wire technology.
Hello everyone, I'm Atul Bhosle. I'm studying MCA at Modern College of Engineering.
Hi guys, myself Paresh Peshwe. I am a student of MCA in Modern College of Engineering.
Hi, this is Kamlesh. I am a consultant and working for various domains like hospital management system, telecom, and work with various technologies like J2EE middleware, BI, data warehousing, and mobile technology as well.
Hi, I'm Amitesh and I work for Amdocs. I'm a development manager there.
Hi, I am Hemant. I work with YOB India Private Limited. I am a full stack developer. I have experience with mobile application development, web app development, server side development, and all this kind of stuff.
I'm Yogesh Bang. I'm a consultant, IT consultant. I work in various domains on technologies, phone apps, ASP.NET, J2E.
This is Pawan. I am a Python developer working as an engineering manager for Shop Socially.
Hi, this is Rahul. I'm working as a developer for tax solutions.
Hi, I'm Sandeep. I'm working as a senior developer with Synergip.
Hi, this is Pratik. I'm working with tax solutions as a developer.
Hello everyone, this is Ricky. I'm working as a developer, software developer for tag creations, and currently we're expanding into getting into game engines and game development also.
Hi, I'm Ritesh Advani. I am just now completed my BE in computer science.
Hello, this is Dipesh, and I'm working with Talentica Softwares.
Hi, I'm Darpan. I am a final year student at the Pune Institute of Computer Technology, Pune.
Hi everyone, I am Aniket. I am also a final year student at PH.
Also, my name is Pratik. Uh, I am working from mobile technologies. Currently, I'm working on currently I'm working in iPhone platform. That's
Hi, I'm Gaurav. I'm working in Avaya as a Java developer.
Did we miss anyone? He's Prashant. He works for Sunazip as the iPhone lead, practice lead. Okay. So thank you. Yeah.
Hello everyone, my name is Kaustub. I work as a trainer at CD Infotech and I currently teach Windows Phone 8 application development.
Okay. So that's all of us. I'll let Tom introduce himself and it's all yours. Thanks.
Okay. Is this working? Yeah. Okay. So thanks everybody for coming on a holiday weekend. I think when we scheduled it, we didn't realize it was going to be a long weekend, but glad everybody was able to come. So I'm going to talk about my personal experiences, I guess, as far as trying to make exciting things happen. I spend more time on that with that on Android than on iOS, but I've been doing a fair amount of iOS development as well. And just trying to, sorry? Is there a volume? It's on. Yeah, it's on. Should I move it closer? Okay. And, you know, trying to do things that haven't been done before on mobile, or trying to push the edge and make things more interactive. And at the same time coming up with ways to do that that aren't going to make your life impossible as a coder. You know, where there's some deep ways to sort of get in a lot of trouble, and trying to avoid that as well. So my background, I always was doing a lot of computers from when I was a kid, but I ended up, it's a little high. Can you turn it down a little? I'm getting some feedback. I'm getting feedback. Yeah. Okay. Maybe, okay. So, but ended up moving into trying to do things that were more creative. So I got a degree in art and semiotics, which is basically a French philosophy on finding how words and symbols get their meaning, which sort of takes you in an area of film theory and linguistics and things like that. But started working doing computer graphics research under Andy Van Dam, who wrote this really big, thick book, one of the co-authors, Foley Van Dam, the introduction to the computer graphics textbook, and he also created the very first hypertext system back in 1968. So got a chance to work with him closely and got into a master's program under him, and ended up getting that research funded by NASA Ames to do goggles and glove virtual reality back when that was a big thing. So ended up, that funded my master's thesis. Along the way, I also got a chance to work with a filmmaker to do some collaborative hypertext and film things that ended up becoming the first film on the internet. A little bit strange to be in the right place at the right time. That led into me getting heavily involved with VRML, which isn't so well known anymore, but it did end up getting slipped into MPEG-4 as one of the features of MPEG-4. So if you wanted to do 3D modeling inside of MP4, it actually is supported in some systems. After that, I ended up working at an early e-commerce company, making some early Java ad banners back before people really understood what advertising on the internet meant, but got a chance to do some of that. Then started my own company and created some techniques for embedding advertising in music and videos and MP3s, and got some patents around that, also some patents around some earlier technology. And then worked for some app companies. I'll talk more about that in a little bit, so just fast forward through that. And then about last year, decided to strike out on my own. And I'm here in India because I'm married to a Bengali woman, and we have 3 kids, and we're trying to spend at least a month or 2 every summer here. We came out for a wedding in Shillong, and we've been in Pondicherry, and so got a chance to come out here. So this is the girls. This is at the wedding. This is a juice break in the middle of the wedding. The 3 on the left, the one on the right is a cousin. So what have I worked on? So obviously Dropbox is a big service. It's done pretty well and consistently grown, and I just checked it. I'd always been saying 50 million plus installs, but I don't get details anymore because I'm not there. So I sort of rely on what Google Play says, and Google Play says now we're over 100 million users, so I was like, okay, time to increase that. And it's bundled on a lot of handsets, so that helps. And people like it. I think it could always do more, but once you get 100 million users, it's really hard to make a dramatic change to an app without worrying that you're going to be breaking it. You can start to get very conservative when you get that kind of user levels. It's a little bit. I was actually intimidated when it got 20,000 users, thinking, oh my God, if I break it, what's going to happen to these people? So, when I left Dropbox a year and a half ago, it had about 5 million users. So that's all growth since then. I took it from 1.0 up to 2.0 up to the 2.0 launch. In the first year, I was by myself working on that. And then after the first year, the next 6 months, we got 2 more people working on it. So we got some pretty good numbers with a very small team, which is one of the things I want to talk about, is just having a small group, very selective group often does really well for you. Dropbox for the longest time had 30 employees, even when they were getting 20, 30 million users. And that's the product discipline of it all. Magic Piano was Smule. They first became well known because they had this iPhone app that you could blow in it and do the ocarina as a flute thing that you could play. And started working off of that and doing more other instruments. So I got brought in to figure out what you could do on Android. And it did well. It's not as high now, but at one point it was the #2 music app. And it does basically, with all these game and type things, they're very choppy. You'll go up really high when you have a marketing push. You go down, you go up, down. Whereas something like Dropbox basically just consistently stays at a certain level. Whereas the game apps are all over the place. So, and that's had quite a substantial success too, though not as good as Dropbox. But people seem to like it. And that I did with 2 other developers. One who worked for DigiDesign and had a PhD in music, so we had a really good technical team on the music side of it. And I'm going to talk in more detail about these in a bit. I just finished working on a pre-launch iOS app that I can't talk about, but it's intended as a drop-in replacement for contacts, but doing everything much smarter and everything like that. And the main reason I'm going to talk about this is because it had a different architectural focus than the other ones. And I'll talk more about that later. And then currently, my company is OMobio. And our goal is, you've got this crazy device in your phone that has all this stuff in it, but what can you do with the 2 cameras and the microphone and all these things? And you've got almost a desktop class processor, as far as at least as pure gigahertz. Maybe not as much as data throughput as you get from a heavyweight Intel class processor, but it's powerful. And what can you do locally on your phone that's not just swiping through panes of to-do lists and emails and things like that? What are the kinds of new applications that you might be able to get from this thing? One of the things I've actually ended up becoming friends with a professor at Berkeley who has a research group which is all around this idea of taking existing algorithms and including things like speech recognition that you couldn't think would be able to be accelerated on a GPU. But so obvious things like Fourier transforms and these types of image processing tasks are very well suited for GPU programming. but what do you do with graph traversal, and what do you do with these kinds of Markov chains and things like that? So they've taken a lot of these algorithms, sped them up 10 to 100 times by moving them into the GPU, mostly focused on desktop. So I'm working with him to try to work out applications for taking these types of applications that are really unprecedented for speed up. You've got an algorithm, you can speed up 10 to 100 times, you can carry it on in your pocket, but what kinds of products can you build out of it? And that's actually surprisingly hard. You can spend a lot of time working with all these great tools, trying to figure out what to do with them, but coming up with a product like Dropbox or something like that is actually, it's hard. It's hard finding the edges of what is and what isn't, and is this something that Google's going to be doing in a few months, and if not, how can you adjust it? So I'll talk a little bit about products, I think, but that's not the main focus. And so the first thing we're working on is something called a Vision Quest, which is we're going to be launching in a few months, at least into beta, and launching simultaneously on iOS and Android, and using computer vision techniques to create a game. And fortunately, we managed to find the right cable, so I can actually show you a demo. So thank you, Mukund, for arranging for that cable. So why am I in mobile? Why is it interesting? I think all of you guys are aware of this, but it doesn't hurt to restate it, which is, right now, it's, Android is the dominant operating system on the planet. So we never thought, this is Linux desktop is actually mobile. With over 1 billion Android devices, over 1 billion iOS devices, according to Apple. And nobody's selling desktops anymore. And as they get more and more powerful, and you have USB hosting and Bluetooth devices, and now with Google's Chromecast, you don't really have any reason why you couldn't use your tablet or your phone as your main computing device for non-intensive, geeky kinds of things. So you'll still see them, but it's the same reason why very few people have full desktop computers anymore. Everybody's moved to laptops. I think there's not going to be any reason to have a laptop shortly, besides having a big display, which Chromecast gives you. But we've got this new thing. We've got a device like this that we carry around with us everywhere. It has 2 phones. It has a couple microphones usually, sometimes really high-quality microphones. It's got a built-in GPU. It's got a few cores in it. 1.5 gigahertz processor, some of the new ones coming out. And people are not building, a lot of people are just building existing apps over again. Or building, basically things that let you swipe through, friends and things like that. But there's, Google is sort of pushing the envelope as far as crazy uses of the technology. But they're also only looking at billion-dollar markets. So my gut feeling is that there's a lot of these $10 million, $100 million markets that Google hasn't been looking at, but that you could do something very cool with heavily accelerated image processing and audio processing. And in addition, you've got built-in databases and everything else. And the real big winner of this, of course, is you can say you can go out to the cloud or you can do it on the device, but the real big winner is the fact that this has 3 or 4 different radios in it and can go out to the cloud as necessary to do all the heavy lifting. So you've got this device for responsivity, for local caching, for pre-processing data heavily, and then you've got the remote cloud for doing anything that requires fusion of inputs from multiple devices and things like that. So I think that's the real winner is both of them combined. I'm going to be mostly talking, though, in this talk about client-side stuff, because I think there's a lot of people who are doing the server-side stuff, and my personal interest has always been more really fast stuff to do on a constrained platform. So here's the Samsung Galaxy S4. The specs for it as far as what kind, it has these gyro sensors, accelerometers, temperature humidity sensors, a Hall sensor that tells you whether the cover's open or closed, all these crazy sensors. We're getting all this information. We've got, and Samsung actually is doing some cool stuff with this stuff, but I think that there's windows for other people besides Samsung and Google to be trying to do cool stuff with these devices that they've built. But one of the main problems as an app developer is that you can do all of it, but it's really hard to do it well. And especially, at Dropbox, we spent a lot of time debating even whether how often you use SSL, how often you sync, how often you upload the photos, because all it takes is a few users whose battery goes to nothing after a few hours of using your app to post some bad comments, and all of a sudden, people are pretty upset, and people stop using it. So the main focus really is just trying to minimize, especially radio network use, and that's one of the reasons why I think that local processing of data is extremely important. You think apps like Siri or Google's voice recognition, and all of them rely on a call up to a server that does, a cloud server that does all the processing, and then it comes back to you a few seconds later, depending on your network connection. So it's not responsive. It's using up a massive amounts of power just to transmit that signal. And then we talk about things like GPS and all this multiple cores, and you've got all this processing in the background, and it's really a delicate balancing act as far as how you manage doing all sorts of cool stuff, and at the same time making sure your users know when they're going to be doing all sorts of cool stuff, and when and making sure that you're unobtrusive otherwise. I know Motorola's new phone also even has background voice recognition, so it's always on and processing even when your phone's mostly off, and it's actually doing it. So that's an example of something that, unless you're extremely careful, which I believe they were, you can't, you have to really worry about it. And fortunately, they have the control of all the components and all the circuits, so they can make sure that works. But some people recently have found that when they were analyzing third-party apps, was that at least for things like any of the ad-sponsored freemium type games, that 70% of an app's power draw was from things that were not a core part of the app. Counting things like geolocation for providing location information for ad serving, all these drop-in ad networks, all this, all the bug reporting, error reporting, all of these frameworks that we use. So I don't have a good answer for this, but some of this stuff, these bottom parts, are more programmer-oriented. Some of these are more business development things, and this, and some of them are just, you really need to have them. But at least I know I've had to integrate 3 or 4 different APIs and with different companies doing the exact same, some version of crash reporting, some version of logging, some version of analytics, and it always just felt very messy and redundant. And I just feel like there's a market niche for somebody to solve this problem. This isn't something I've solved, but you definitely have to think about it a lot when you're going to build an app that's going to go out to millions of people. So how do you mind turning that down a little bit? I'm getting some feedback. Is it this one? See if that's a bit better. Can you still hear me? Or did I turn it off entirely? Okay. This is mostly for the camera's benefit. No, it's not. Okay. Let's see if that works. Okay, so, no. Don't touch the very fragile knob. No. Okay. Yeah. Okay, I'm not hearing so much feedback. So a lot of people, when on the comments for the meetup, were asking me about HTML5 approaches and web views and things like that. And honestly, I don't know a lot about them. I haven't spent a lot of time. I just wanted to cover it. I just wanted to mention it because I know a lot of people are working in these. Historically, they haven't had good performance, or they haven't let you get deeper into the phone. I think a lot of those problems are starting to be solved, but I've as these frameworks get better, I'm looking at what can you do that goes beyond what those frameworks can easily do. And you end up with basically a bunch of things that are easy to do, but I don't. So now that it'd be really difficult to build Dropbox on top of that. It would be impossible to build, a game app on top of these things that tried to do anything reasonably fast. So any of the stuff that goes beyond what the framework allows for, what JavaScript, or it tries to do crazy processing that JavaScript isn't capable of, is going to fall short. And I've definitely found that, at least historically when I looked at these, was things like throwing the screen ended up being very choppy. Things like waiting for rendering, and you also have to, it's hard to manage the code, whether which of your JavaScript, HTML, and stuff is going to be cached locally on the device, which is going to be coming in dynamically, how do you update it? I think there's a good place for these kinds of things in peripheral parts of an app. You know, like if you need a good help system, or if you need the settings management, or parts for maybe user profile management, things like that. I think that's still reasonable. But I guess I'm looking at apps where the core part of it has to be super responsive, and I haven't been able to find a framework yet that provides that. So my first app I ever did was writing Dropbox. I'd been doing mobile development a bit before that on other platforms, pre-Android, and been doing a lot, worked on computers for a long time, so I got into it. This isn't really a cross-platform app, of course, just they have separate apps that all do the right thing, so that's why I did it. So basically, each one of them wrote their own, each group is its own independent app. Even BlackBerry and Android didn't share any code because the BlackBerry Java is sufficiently different from Android Java to make that pretty useless. And it works really well. It's a pain in the butt and it's really expensive. And you have to have different groups, teams to do it. But you can, if you really want to make something that integrates really deeply with that individual operating system, it's in a really native way. It's really the only way to do it. So yeah, I actually didn't even look at the iOS code much as I was writing it. I just said, okay, we're going to write something that works a bit like the iOS one. It's going to have different integration points because we have things like intents in Android. We have things like, we are able to access, expose APIs between different apps that iOS can't do. And additionally, we've got the benefit of iOS Android had to build its own stovepipe viewers for here's a viewer for documents, here's a viewer for, for all these things, because it was difficult at the time for iOS to send data from one app to another. Some of that's been solved, but still not as well as Android solved it. With Android, we got the benefit of it going into this Office viewer, this PDF renderer, and just having it do the right thing and launch it separately. So it worked really well, but and we talked about at some point about having some shared code between iOS and Android, but it would have all had to been C code, and still probably wouldn't have. It never happened, just because the systems were sufficiently different, and the way users use them was sufficiently different. So this is the degenerate case of a cross-platform app where you don't really do it. So I think I said most of this. That we use SQLite really heavily, of course, in that, and actually I modeled the SQLite after the use after the desktop client more than that. We didn't actually model much else after the desktop client because the desktop client was all Python code. That was doing a lot of deep file syncing that wouldn't have been as appropriate for a mobile app, especially as far as network usage and things like that, and all the file hashing and things. So looking at it as its own thing, we ended up mostly, almost completely using the public Dropbox API. So just in case you guys ever want to build a better Dropbox app, you can do almost everything the Dropbox app does using the public API. There's really no internal stuff, except for some OAuth stuff that lets you third-party apps work with Dropbox. There's really nothing that that Dropbox is doing that it wouldn't be possible for a third-party client to write and do better if you felt like you could. But it's really hard, the syncing. Well, let me first show. So you probably all used it, but this is shots from Google Play of it in use. We had a bunch of features we did, which were nice as far as integrating deeply with different OS features and doing a lot of intents. And that was actually very fun work to do because we'd have to say, oh yeah, Quick Office needs to be invoked a certain way. Let's have a special way that this works with that, and we'll have to drop stuff into the right spot in the file system so that these guys can use it. So there's a lot of code, getting comic book viewers to work properly for people who have custom comic book rendering formats that get used in funny places, and trying to generally do a lot of heuristics about what app to start, even if you just have the extension or you don't have the right MIME type. It turns out a lot of apps give really bad MIME types, so that makes it interesting to try to figure this out. So yeah, we integrated with pretty much everything we could. Built our own photo browser, which was also a fun project. Turns out that most people do use Dropbox for photos, and so that's when we started adding the automatic camera stream upload feature and giving people extra size for it. And which is about, I left shortly after we got all that working, and went on to do my own projects. But this last piece, the OAuth management, that's the only part that there's a special Dropbox API to handle that. Everything else, like I said, you could write a better Dropbox app if you wanted to. There's an interesting programming level problem on this. Is you've got, this is all too small to read, but you've got 4 different things that you've got to keep in sync. You've got your local memory data structures over here that are generally local caches of metadata, stuff you're using for rendering what the files are right now. And a lot of that, some of that stuff is used for like when you're displaying browsing a directory or whatever else like that. You've got some version of the SQLite database that also is storing a lot of this information. And these, for example, if you just had memory in a SQLite database, it's pretty easy to handle that, keeping things in sync. You've also got a file system which has a cache for thumbnails. It has a cache for files. Some files have been made dirty in that they have to be uploaded to the server. Some files are older copies of things that have to be re-downloaded from the remote server. And you've also got this remote server that's using JSON. And this isn't just a Dropbox specific problem, but I'd say this is, that was getting this problem solved is really actually quite hard. It's any one of these, it's pretty reasonable to sync to each other. But keeping 4 things in particular in sync, I couldn't find a good solution for. Yeah, so there's this algorithm, I don't know if you know Richard Feynman, but he was Nobel laureate and all that. And Murray Gell-Mann, who coined the phrase quark, said this is the algorithm he would use, is you write down the problem, you think real hard, and then after a few days you write down the solution as the main technique he got to solve things. And this kind of thing works for hard problems. Getting back to this, you can come up with multi-threading lock mechanisms, you can come up with data sharing mechanisms, but this 4-way sync thing is really hard to do well. You could even think of, you could have like a hub system where everything is syncing to some hub, or you could say the remote server is the master, everything else is going to sync based on that. But it's not really true, because sometimes you've got all your camera photos you take, you might edit a document here, and now this becomes the master and you're syncing it back through here. You just end up with a lot of edge cases. So you get, with the syncing process, you can drop your network connection, you can change over from 3G or 4G to Wi-Fi, you can end up with somebody editing something locally and remotely. Dropbox solves that just by refusing to merge them. It just creates duplicate copies wherever possible. But it's hard to, if something's close enough together, it's hard to test that one. If I edit the picture, I might have my thumbnail cache. My thumbnail cache doesn't always know that the picture's been edited, and now we have to go and regenerate the thumbnail. When the Dropbox app isn't running, if somebody opens a Quick Office document, and it's been opened already from Dropbox to Quick Office, Quick Office stores a little shortcut to the canonical path that Dropbox stores it from. So Dropbox is no longer running. It doesn't know that that file's been changed. Somebody starts up Quick Office, it shows it as a recent entry in your documents. So you go and you edit it, you save it. The next time Dropbox starts up, it needs to, I think actually right this time mostly, most of the time now it picks up that change, but that was actually a hard problem to get right, to go through and recheck all the files on the cache and make sure they haven't been changed since the last time you run, and try to do some local hash computation and re-upload. But that took us quite a while to track that down and try to come up with the best solution to that problem. You've got partial uploads that you don't really want to, if you've got a 2 gigabyte video that you've just captured, you don't want to keep trying to, you don't want to get halfway through the upload and then have this connection go and then try to re-upload another 2 gigabytes of data. that gets pretty awful for the users. It'd be nice to be able to do partial upload and downloads, although partial uploads and nobody, EWS didn't support that for a long time. And in general, it's not a problem that's well solved with HTTP. This was another one that was pretty interesting. I didn't know that there was a 2.5 gigabyte file upload limit internal to Dropbox. It's not actually in Dropbox. It's in Nginx layers. There was a limit on how big the files could be uploaded, which wasn't a problem for the desktop clients because they split them up into chunks and uploaded each chunk separately. But the mobile app didn't support that, so you'd upload a 2.5 gigabyte file, and then you'd get a response back that said the file's too big. And until we started checking explicitly for the response, you just assume it was a failed upload, and so it'd keep trying. And it'd keep retrying that until your battery drained. So these are all things that are really a pain to get right. And then you have other stupid things, like if you have a bug where something gets updated in your SQLite database wrong or stored wrong, it can actually end up propagating through the whole file system and end up getting back into the server metadata until you've got, you end up with some corruption because, a slight change to the data in the wrong place ends up with you uploading the wrong version of the file and so on and so on. So even at Dropbox, where this was what we were doing, I'd say this was a difficult task. If you're looking at, most apps do have some version of this stuff, and it's not a well-solved problem. I think parse actually is, okay. Everybody remain calm.
It is the fire alarm, but wait for it to get reset, please.
Should we take our 5-minute break, or? Okay. All right. Okay. So I'd say something like parse actually does a pretty good job of handling this kind of state propagation. So actually I was thinking for a while of, when I left Dropbox, starting something like parse until I found parse, and I was like, okay, they're awesome. Yeah, sure, okay, yeah. Why don't we take a stop, and anybody have some questions so far?
Ask your questions on the microphone so that we...
I have a question on partial upload and download. Is this HTTP partial upload and download? Or it's some native protocol?
You have to hack a protocol, and Amazon came out with a proposal for it a couple years ago that they implemented for partial upload. But it's not something, partial download, chunking and things like that it's a bit more, that there's part of HTTP that handle that. Partial upload, though, there wasn't any normal way to handle that.
So there's no RFC for that?
I haven't seen any, but that was, the last I looked into this was a couple years ago, so it might have changed.
Yeah, because,
but I haven't seen. I mean, Amazon came up with a protocol that I think other people started implementing, but I don't know if they formalized it into an RFC.
Okay, so it's a native implementation by Dropbox.
Yeah, well, no, you basically have to do something like what they do, and you basically, to do partial upload, there's no way. You just pre-chunk the file. You upload a little bit, you upload the next, you upload 1 meg, you upload the next meg, you upload the next meg. At the end, you have to say, have something to confirm that everything's finished, and you have to tell it to stitch the file together. But so that's the basic way to do it. But there wasn't anybody who had done it right, in any standards compliant way that I saw.
Okay, thanks.
Any other questions before we move forward?
Yeah. Do you have any design pattern or any rule which says how much should be computed locally and how much should be computed on the server? What is the relative cost in terms of power management?
That's a good question, and it's a hard, it sort of ends up being a bunch of rules of thumbs as far as these things go. I mean, the obvious thing is if it costs more bandwidth to transmit the thing over to the server than it would be to compute it locally, it's a good place to optimize. But no, I think that's where some of the magic and the sort of balancing of things that you have to do. It's a gut feeling because, not everyone's going to use the app in the same way you use it. You could have a solution that works really well for small files and not for big files and vice versa.
Is it possible to pre-compute like the cost of a certain, executing a certain function here or there? Could you pre-compute it and then decide at runtime that something is better done over here or something?
I mean, I think if you, okay, let's just say hypothetically you had a pure JavaScript-based system, just so you had the same language on the server and the same language on the client, right? You could hypothetically have a sufficiently smart compiler that could do some of that where, basically find the cut in the graph of computations that where the cost was less to move it to the server or the cost was less to move it to the client. And that would be a really cool system to have. But I haven't seen anything like that. In fact, that'd be great for web development in general and things like that, is if you had something that, say, using Node or something like that, that would just automatically move stuff back and forth between the server and the client and partition it properly. Probably be a really cool product, actually, if you should go build it. Okay. Oh, yes.
So the problem which you talk about syncing the files, like in case of remote changes and you have a conflict, then you have to choose one file or let's say merge them, something like that. So see, the same problem was with Quick Office as well, right? We faced the same issue, but then yeah. So how did you guys solve it? Like, you said that you just discard, you just make a copy of it, because until there is a network connection, we can't really give a good feedback to user whether what's going on in the scene. Like, he can just type in, and at the end, when the network comes, the file may not be there on the server, might have deleted.
No, it's a hard problem to do well, and that's sort of why Dropbox just said we're not going to handle file merge. And we're just going to, whenever there's a change happening, you just split it off. There'd probably actually, that's another probably market I've thought about, is it'd be nice to have a tool to re-merge them back in. You'd have to be smart about different types, but you end up, just in general actually, being able to merge the documents smartly and things like that. It's hard to do with every kind of document type though.
Yeah, every kind of document is a great thing. Because I think Apple does it in iCloud, but it was tough to support other services.
Yeah, when it works, when you can do merge right, it works well. But the problem is there's so many kinds of files, and some of them are really fully binary, and you can't. I mean, with code-based tools, we do it all the time with Git and stuff like that, and that generally works. But if you have a JPEG, what do you do? If you have a Office document, that you can do it, but it gets trickier. If you have a movie, I don't know what you do. You had a question?
Yeah. Earlier in the slides, you said that 70% of average app battery usage is not core stuff.
Yeah.
My question is, if I were to make an app, how would I measure how much battery is it consuming?
Well, they were doing stuff like they actually had it hooked. They found a phone that exposed the current draw, and they were able to shut down parts of the the display and things like that. They were doing a lot of funky things to figure that out. I think if you Google for it, you can find the methodology they used. But I think there's another cool product, I think, would be to come up with something to help people understand where they're drawing current and split it out. You get some visibility from Android, but in general, yeah. But I think to do it right, you need to have like a voltmeter and things like that to really get it fine-grained and accurate.
I use a Power Manager app on my Android.
Yeah.
But then if I were to build, I have never built one. If I were to build an app and I wanted to know how much battery does it drain, I won't get the actual currency value of it because there are so many other apps which are running in parallel along with it.
Yeah.
So if I wanted to know what is the percentage that this particular app is affecting, so I could actually try to optimize it.
Yeah, I think it's right now you sort of have to go. I mean, it's unless you're willing to do something like what these people did, where they basically ripped apart a phone and were measuring currents and things like that. But I think like these are areas that I think someone should solve, giving support to a user. Even if you had to go and say, okay, give us your app and we'll measure its current draw in all these different situations, and we'll tell you what the user is going to experience. This would be another opportunity for something. Yeah. Okay.
Yeah, regarding that problem only, there was some hardware I had seen from Texas Instruments that you connect your phone's battery and all those connectors to that instrument, and that will do all the tasks for you. So, what you are telling about, about the phone and all.
I mean, I think the problem is, it's like we're so willing as developers we've got all these amazing high-level APIs to parse JSON and not realizing that it's building megabytes of data in the background. Actually Java reflectivity turns out in Android turns out to be really bad. So anytime you do annotations and you try to do smart things based on Java annotations, it actually allocates a couple megabytes of data to do that. So your app ends up freezing up just because you're doing all this reflection. I'm going to talk a bit about that in a little bit because I came across that in another app. But just a lot of this really cool high-level stuff is really hard to, is really easy to add and really hard to figure out what's going on under the hood.
Yes, sir. Is there any kind of dedupe solution to minimize the traffic?
If you see the other problem with these things like ad networks, you can work with just Flurry or just one of these other ad networks. The thing is, they all come up with a super API that lets you also serve ads from all these other. Every one of these ad networks is trying to be the primary ad network. So, and their API all talks to all the other ad networks and lets you embed things from them. So I think there's ways, but a lot of that is sloppily coded, and it's hard to pull that. And at this point you have to have ads and you have to have ad networks to make your app monetizable in most cases. And so you have to rely on them doing a good job, unfortunately. And I haven't found that there's always the best coding under the hood with some of these things. Also, the ad networks often have different models of how you place it and whether it's full screen or whether it's, what their sizes are, and they often don't shim that very well when they're, when you're dealing with one ad network delivering ads from another ad network. There's often gaps and crashes and things like that. So, okay, I'll keep moving forward then. By the way, what you said we wanted to have a break about halfway through. Is that what you're saying? Okay, I'll try to time things that way. So, so you talk about you have this problem, this four-way thing, and people say you should do lots of unit testing, and I definitely agree with unit testing for core stuff. Like Dropbox's core API, we had a bunch of unit testing in. For things delivered to third-party users, you had a lot of unit testing, and it's really critical for anything that's low-level and especially things that are externally facing, that if you make bugs, it affects a lot of people. So you want to, for things like that, you'd want to test all of that. We actually we didn't have as much unit testing on the actual app, and I think there's a reason for that, which is that it's sort of like, every time you're building up unit tests, you're building scaffolding around your whole building, so that to fit exactly the structure that the building is. And if anything changes, you have to re-accommodate that whole restructure all over again. And it's great for core things that you want to behave like that, but things like UI, where you're going to be making a lot of changes to pixel spacing, you're going to be making a lot of changes to layouts. If every time you do that, you end up having to fix 30 or 40 tests, you're not going to make a lot of changes to the GUI. And so I actually believe that you probably shouldn't do so much unit testing on things like GUI elements and things like that. Unless, of course, if you were a GUI element company that had to make sure your checkboxes all looked right, of course you should do it. But I think in general, for a consumer-facing app, I've been relying more on just general integration testing, where you go through and physically check every box, and you've got these 250 steps you have to carry out. And actually, at Dropbox, we didn't have a separate QA department at all. The developers, when we got ready for a release, we would go through and spend a week doing QA on our own code. I'm not going to argue one way or another about that. I was actually always wishing we had a QA department, but it certainly makes you a lot more willing to fix things if you're the guy who has to test them all the time. So monkey testing turned out to be one of the best things for it, and we did that because Samsung mandated it for an app to be integrated on Samsung, and it turned out that that exposed so many low-level, weird threading bugs and things like that, where if you touch this button real fast after you touch that button, the app would crash. And it took us quite a while it actually exposed a lot of bugs that we hadn't really even thought about as far as race conditions and things like that. So I really recommend monkey testing, especially since it's so easy to do on Android anyway. It's just one command line and it runs and either the worker does it. And then, say the number one thing that really helped us build a really solid app was now I would use criticism. At the time it didn't exist, but so we built our own framework for catching crashes and uploading them to a central server and then doing a lot of data analysis on common crashes. So we'd build up, create an APK, post it on the discussion forums and saying, here's our new beta, or we try it out. We might get a couple thousand people using it. And we start getting crash reports, and then after 2 weeks of fixing all the top ones, we then get ready for a full release of it. And I'd say that was the number one way that we got a really solid app, was because there's just all sorts of stuff that you can't test for in any of these ways. You know, somebody has some oddball phone that sets one critical setting by default to a different setting than every other phone. I think HTC had a lot of funny handsets, but there was one thing that said if you had a text buffer, it would set the default length of a text buffer to 50 lines instead of, 40,000 or whatever. That's the regular one. It was an actual setting that defaulted differently, and we didn't find that out until later. There was another one of the first LTE phones that we got. It set the TCP buffer size to 1 megabyte instead of a few K. I think because it made it look really awesome when you were doing some benchmarking to show just how quickly the video was streaming through the device, which is great if you have one connection. We were doing like 8 connections in parallel, mostly downloading metadata and things like that. And that ended up being 8 megabytes of buffers that are allocated for that. So all of a sudden, everybody using that phone ended up crashing. And so little things like that, where that one phone, the developers, the Samsung, the handset manufacturers decided, let's go through and mess up everybody's experience so that we look really good on these benchmarks. And you just got to do a lot of random fixes like that when you're out on everybody else's device. And I think we're going to come to a natural stop in a little bit, so I'll finish up this section on Dropbox. As an aside, just because a lot of you guys are involved in products, I think one of the people who was at Dropbox as a product manager, he'd come from Google working directly under Marissa Mayer, and he said that he hadn't seen that kind of product discipline from any other company, besides Google, as far as trying to keep things as small and tight as possible. Of course, now Google's everywhere, but this sort of like the prototypical example being the Google search page as having as few elements as possible. That Dropbox really just is an icon and as few settings as possible. And we had all sorts of stuff that people asked for in the forums. People said this is the thing I absolutely have to have from Dropbox. We'd like, okay, let's hack it up. It can't be that hard. And a couple weeks later, somebody had implemented it, but it made the product too complicated. It required a couple settings. It required some confusion. Certainly if an engineer gets confused, there's a prototypical example. People are asking for the ability to sync any folder in Dropbox, which you think, okay, that's not hard to do. It's a rough correlate to the symbolic link problem, which every time I want to do an ln-s of some directory, I get the parameters backwards every single time. And I think most engineers I've talked to have that problem where, as an engineer, if you get confused about the ordering or placement of what happens when you're taking one directory and making it point to another directory, you're never going to expect your grandmother or your girlfriend or whatever to be able to use a product that has something that an engineer can't understand. So, so I think that kind of deep product discipline of refusing to add features that would wreck the product, even under the face of developers of a lot of users wanting it, knowing that it's going to wreck the product or knowing that it will confuse things. And it's very easy as a developer to just say, hey, let's just, okay, no one will care, someone will care about this, let's add it to the settings page. And I actually, when I first got there, I was saying that too. Like, oh, okay, let's do this, but if nobody needs it, we'll just put it on the settings page. And I got slapped on the wrist a few times because the whole philosophy was it just works. That was actually, we had a big neon sign saying it just works that they made up. And every so often the it and the S and the work would fall, it would just turn into just work instead of it just works. But anyway, I mean, I think this is this isn't. It's not tangent. It's not a core part of what I'm talking about. But I think it's a lesson learned that I'd like everybody to try to pick up as far as anybody who's designing their own products. And this gets into the whole question of minimum viable products and rapid prototyping and all these things. And I think if you keep your core product as simple as possible, it makes your life easier in general. So I think we're ready for we can do the break, and then we can talk about the rest after this.
So we'll have I guess a 10-minute break.
Okay, and but before that, does anybody have any questions?
Yeah, we could break out and have the questions.
Okay.
There are some refreshments outside, so you guys can help yourself.
Okay.
And we'll gather back in 10 minutes.
Okay. So while we're waiting for everybody to filter back in, does anybody have any other questions right so far? Okay, but I think you need the mic, yeah. You might have to turn it on.
Okay, so you have touched base upon the Bootstrap frameworks, to create applications. Some of them are Sencha and PhoneGap.
Sorry, I'm not following you.
You have touched base upon one of the framework web views like PhoneGap and Sencha in order to build the applications, mobile apps. But I have heard about other frameworks which provide visual elements to create applications.
Yeah.
So is it worth looking into those options?
Well,
how do you think on that perspective?
I mean, I think these frameworks are all getting better. They're like a couple of years ago they were not doing a very good job, but everybody's adding in a bit more features and getting a bit more solid. In fact, I'm using a C++ cross-platform framework for the current app we're building. So there's a place for them. You just end up with this constant tug of, anytime you're using somebody else's framework, you have to ask how easy is it to break out of the framework when you need to. Because inevitably there'll come some time when you're not getting the performance you need, or you just need to add a little control in one part of the screen, and there's no easy way to do it because you don't have a way to do that. So I'm almost thinking with these frameworks, the lighter weight and the less they do for you, you might have to do a little bit more work to get something done. It's sort of like with Ruby on Rails, right? Ruby on Rails is great to get stuff working really easily, but it's hard to get it to scale well. It's hard to, if you want to do something that doesn't match up the Ruby on Rails methodology, it's actually really hard to break outside of that. But for getting stuff working as a prototype, or getting you to scale Twitter, started on Ruby on Rails, and they had to eventually rewrite everything from scratch to get it to continue scaling. But you get 90% of the way there, and often that's good enough to know whether you've got a good product or not. And they keep getting probably now they're getting to you to 95% there because they've improved a bit. But just always be careful. The frameworks that do more for you often are harder to break out of. And sometimes you just need a simple little medium level framework that gives you 80% of your functionality, and you can do the other 20% reasonably easily, rather than having something that does 95% and it's impossible to do that last 5% that you really need to get working. So I'm going to talk about next. So after I left Dropbox, I started working I thought, if I can do a really good utility, that's one thing, but let's try to learn what I can about games. And I liked what Smule was doing. I really loved the Ocarina app. It was one of my favorite apps when they came out with it on the iPhone. And went and talked with them, and they said, we keep, actually the CEO who started it had made some very public statements about how awful Android was, and they'd never do an Android app. But their investors kept saying, well, we need an Android app, we need an Android app. And he's like, well, it's impossible to do any good audio on Android. So I came in with the mandate to try to figure out how to do something good for audio on Android, with the understanding that if it was even halfway workable, we'd still ship it because there was just enough demand for it. So they had a very messy, very large code base. Well, no, medium large, not very large, medium large code base, which was a lot of heavily hacked on C and C++ code, originally developed for computer music applications by musicians rather than by programmers. So it was very messy, but it was all at least in C and C++, and it had Objective-C littered throughout the code base. But it turned out somebody took it upon themselves to refactor that out and simplify it. So at least I ended up with something with just a few handles that I had to write a JNI wrapper to and basically get it to compile. I'll talk a bit more about this last piece, which is one of the things I didn't like at Dropbox was if you're writing a syncing layer for something, that you put all your energy into the syncing layer, but how do you, as a normal person, this is also pre-parse, but as a normal person, how do you write something that basically, instead of, you write code that parses a JSON, turns it into a Java object or into an Objective-C object or whatever. You write code that stores it to a database. You write it stuff that's serialized. You might have to serialize it a different way, and there's always different steps where if you add a parameter, sometimes you have to touch 4 or 5 different files to get all the parameters added in the right places, and that always bugged me. So I was looking at using Java annotations for this. Which actually is incredibly cool way to program because you basically have one Java file and it has all these basically a little annotation that tells you how to write it out to an ORM or how to serialize it to JSON. And it saved a lot of time developing, except for then we found out this problem with Dalvik where reflection ended up consuming tons of memory and slowing down. Something that could have been parsed in a few seconds ended up taking 30 seconds or a minute to parse, and that ended up becoming a bottleneck instead. So it's what we talked about with the frameworks. You end up with something that does all sorts of cool stuff and makes your life as a programmer easy, but at the end of it, you were like, why did we do that? I've had a lot of problems with Apple's own own object model implementations and things like that, where basically on one level they save you a lot of time, and on another level you're always dealing with some crazy amount of messy seams and things like that. So this is what it looks like. You're multi-touch. This is all OpenGL, and you're playing piano. This is a piano score, and lets you download some songs, and you've got some different piano versions. To get this, the graphics wasn't so hard to get working, but Android Audio is just a mess. It's an absolute mess, and there's about 4 different APIs to do it, none of which give you any latency benefits over anything, except for one, and I'll talk about it. But generally, from the time you touch in almost any Android app, in almost any phone, and actually the Amazon Kindle ends up with like 400 milliseconds delay from when you touch something to when you first can hear audio coming out of it. So, which is considerable. You can actually do something in 400 milliseconds yourself as a person. And so it was just awful trying to get something to work, and I spent about a month or 2 just banging on different APIs trying to figure this out. And finally we found that Soundpool, which is the oldest API that Google came out with for audio, if you've preloaded your samples and you don't want to do anything fancy along the way. So if you had a flute, if you were playing a flute music and you had control over it, this technique doesn't work. But for something percussive like a piano or a drum, where theoretically in a piano app you could have control over sustain, but if you're willing to give up the control over sustain and any control over the pitch as it's going, you can get something that's more around 50 milliseconds or 100 milliseconds. And it actually ended up, we got that working and dropped it into the app, and all of a sudden I was like, okay, this is something we can ship. I don't even have to be embarrassed about it. Because up until that point I was like, okay, I was regretting even taking that job. Because I was like, I'm never going to be able to make anything good on Android. Why are we even doing anything on Android? It's going to be awful. I mean, part of the reason for this is that Android has really nice object intercommunication protocols, and it's really sweet that you can go and create an intent and send it to another thing, and everything's well partitioned as separate Java processes, so it's inherently more secure. obviously there's always problems with security, but as a design, it's a pretty good design. The problem is that they did that kind of thing for the audio. So the audio you create in your app, then it goes through some inter-process communication to go to something else, and then it goes to a buffer, and the buffers are all too big because Google didn't really care about audio latency. Whereas iPhone, you know, they decided from the beginning, let's build it on a real-time operating system, let's make sure the buffers are small, let's tune every aspect of the hardware to have really tiny buffers. They prioritized it, and it ended up working pretty well. So they fixed this in the latest versions, and if you have one of these devices and you're using OpenSL and you start it with the exact right sample rate and you do everything else, all the right black magic voodoo, you can get a very good audio experience. But only on those 3 devices, as far as I know, and only if you have the exact right type of audio that you're going to play. So Google's fixed it, but you're dependent upon the rest of the ecosystem to try to pick up their fix. Any questions about Magic Piano before I move on? Audio? Okay. Then this is more the approach that I'm, so this is this contacts app that I was working on. They decided that why are we writing all this code for iOS and Android? We're going to, it's sort of like a similar idea with this core that we had for Magic Piano, except that you say, we'll do all the rendering in whatever the platform UI stuff is going to be. Whereas in the Magic Piano, that was all an OpenGL screen. And actually, the core was OpenGL, and then we implemented, basically iOS, we implemented all the auxiliary song choosing screens. All these guys. This is all in Java or Objective-C, depending on the platform. This is OpenGL, this is OpenGL, but a lot of the, the upsells and being able to pick high scores and all that stuff, those screens were all just implemented as regular platform-specific widgets. Theoretically, with this all, you could maybe use an HTML5 thing, but you still run into the scrolling problems and things like that. So with this system, just because they took a different cut on it, they had decided we're going to do a lot of database work. It's got a lot of like AI type kinds of weightings and things like that. We're going to do all locally on the data. We're going to implement stuff to handle email protocols and C to handle all this stuff. And so we're going to write this basic core layer that handles all of that, and then on top of it we'll write the GUI in each language, in each platform. And that worked okay, except that they weren't paying attention when they implemented the iOS client. And the problem is that this boundary got massive. So basically every time you wrote a SQLite thing, they wrote an Objective-C layer around this, you wrote a C layer that talked to SQLite, to that specific table or whatever to represent that. Then somebody would write an Objective-C wrapper around that. And then a whole bunch of Objective-C that called into it and back and forth. And the surface area of the API got extremely large, which would mean that as you port that to Java, you have to sit there and write JNI for every single one of those places where, and it's easy to be undisciplined about that in Objective-C just because it's very easy to switch between C and Objective-C. But on Android, switching between Java and C is a big pain. And they were using a mix of JSON and basically regular Objective-C serialized objects and Google protocol buffers. So everything was getting serialized and deserialized 4 or 5 times, and to add anything to the system, you were touching about 8 or 9 files instead of the normal 4 or 5. And so this is, if you're really doing something that has a lot of low-level stuff and you can really be disciplined about the layer between it, I'd say it's an okay approach. But it's just hard. And then where they were like, well, let's see, how hard is this to put it onto Android? I said, well, I just did a code count, and the guy who developed it was very proud of this low-level searching and syncing code. That was probably 40,000 lines of C. Probably would have been about 20,000 lines of a higher-level language, just because you had to write your own hash tables and everything else. But then there was another 40,000 lines of Objective-C. So you don't really save that much by doing this, and I'd say that a lot of that was just munging back and forth between all these different application layers. This is an app that's going to be released soon for iOS, but I'm not going to say what the name of it is because it hasn't come out yet. And then what I'm looking at right now is this sort of the game engine approach, where you have your, which is a lot like what we did for Magic Piano, where you have this game code that's talking to a game engine. This is all going to be in C, C++. And then you have a bunch of stuff that is written in for in Objective-C or in Java that's going and just talking to Google APIs or Facebook APIs and everything that using the built-in, because you wouldn't want to rewrite all that in C anyway. They've got an API, why not use it? It saves you a lot of time. And so this idea, much like with Magic Piano, where you've got some core IP, like Angry Birds or something like that. You've got some core thing that you wanted to run roughly the same on everything, but you want to make sure that it's decorated with apps with OS-specific widgets, that it behaves in a general way once you get out of that. So that's the direction I'm looking at right now. There's a lot of these things, and some of them that use Lua as a scripting language. There's a bunch of these third-party frameworks that are out there. I'm using Cocos 2DX just because Marmalade does a lot of the same things, and in fact, a lot of these people will integrate with Cocos 2DX at a lower level and write high-level wrappers around it. I'm framework averse, as I mentioned, so anything that does too much, I try to, and it gets too big, I try to find a slightly lighter version of it, just because I know I'm going to be breaking whatever they're going to do, and have to hack around it anyway. This is great. So we've got, in the stuff I've done, we've got a Windows version, a Mac OS version, an iOS version, and an Android version almost for free. And using mostly the same code except for the stuff that, capturing video or stuff, eventually the stuff that, talks to Facebook and stuff is going to have to be rewritten for each individual platform. But still, you've got this, you've still got to hack around, if it doesn't support tilt sensing, you've got to write something to support tilt sensing, yourself. Let's see, there we go. And then what I talked about is getting into GPU computing. So the graphics processor unit on your phone, it's basically really fast at plus adding and subtracting and multiplying and doing things that you have to do to take a triangle and put it onto the screen with the right texture. So a lot of that is basically very basic mathematical operations. And it can do that with sometimes as many as 16 processes working in parallel. I mean, on a desktop, you might get thousands of them. But on a phone chip, you have some very fast, extremely limited processors that are able to work really fast. It's hard to get stuff in and out of the GPU, so you have to manage your memory usage to get the stuff. Basically, you remap your program so it's a bunch of drawing operations with texture maps. And in order to store data, you have to store the data in a texture map and get it back out. And it's a completely different way to think about programming. But like I said, if you work the Berkeley work where they took speech recognition and were able to parallelize it, get a 10 to 100 times speed up on speech recognition. Fluid dynamics, water and wind simulation is extremely well suited for this. So if you wanted to have a game where you had really good water and waves and things like that, it's perfect. Signal processing in general, 2D audio versus 1D audio channels or 2D video or things works extremely well. Somebody went and took a geospatial database and stuff that was taking minutes on just using a regular database. They ended up using the GPU to accelerate that, and we're getting results in sub-second intervals because they use the GPU to manage the spatial queries. And of course, with shaders, you can do all the gamey, cool visual effects. So we're looking at this, and like I've mentioned, we were trying to come up with ways to use the GPU, and it's hard to come up with products, but in the meantime, I thought, well, let's start with this game and see how to turn these things and make it into a product. Right now, I didn't know anything at all about how different phones supported different features and what kinds of behaviors you'd get and how to package that all up and things like that. So rather than just spin my wheels on researching it, I thought I'll do research by making a product. And so we prototyped that in Java for Android and using OpenCV's native code to speed that up. And OpenCV is a computer vision library that was actually used for Stanford's winner of the self-driving car simulation. So if it's good enough for a self-driving car, basically it's got probably about 100 or 200 different PhD dissertations embedded in this code that if you need to do facial recognition, you fire it up. If you need to do whatever you want to, it's just incredibly easy to do. But it turned out that we were getting semi-real time, but not quite fast enough. We were also ending up getting limited a bit by data conversions and things like that. It was almost reasonable, but we said, hey, let's port this to Cocos 2DX, put it in C++, and then we can use GL shaders to do a lot of the stuff that we were doing in OpenCV. So move stuff from native C code that was prepackaged into these shaders. And that might have been a bit of a off-the-cuff decision. Well, I mean, we thought about it, but I didn't realize it would take months and months to get that to work again. But we did. It's now working, and I'll show that in a little bit. But basically, so when you get video out of the camera, it comes in a format called YUV, which is basically compressing video so that the color components, which your eyes are less sensitive to, are at a lower resolution, lower detail than the black and white components that your eyes are very sensitive to. But this saves space and all that, but you have to convert it into RGB to display it. Then we do this edge detection, and I'll show you that in a bit. And then we have to do some masking and cropping, and all these things that we were doing in C++ ended up being really well suited to move into a shader. So this is a story about a young armadillo, a space armadillo, who is sent by the trickster coyote into a world where he has to use the phone, where he has to be able to find his way home. And we were taking, so this is actually a picture of my daughter, where the edges of the screen, the edges of the image are being used to bounce off. So you have to actually build platforms and obstacles in order to solve the problems. And these are some of the, so he's being sent through different worlds. So a forest world where as you take pictures, if something's green in the image, it's going to be highlighted and turned into a special power-up. As you cross the green thing, the Inferno red area will be, red things will be magic. Same thing, blue areas or pink areas. So it turns into sort of a bit of a scavenger hunt to find the right kinds of images to solve the problem. Now let's do the magic of switching cables. And we have it. Oh, wait, that's the wrong one. So here we have the game. This is actually, you can see this is you guys. And so I need to find a bridge to be able to cross over to get to this destination. Let's see that. See if that actually still goes, yeah. And get into the hole. So the edges in the scene, it's highlighting different edges and things. And it treats them as obstacles. So you can, for here you can cross this. So you have to find, it's sort of a scavenger hunt combined with a platformer where you get to cross things over. And you can do stuff where this is much more free form. This is, so we're just basically getting this to work, turning this into some levels, and we're looking to put this out in the next couple months into beta and see if people like it. But it's, to do this stuff ended up being quite a lot of behind the scenes work to get it to work right. But I think this kind of approach where you do something that was impossible before, try to find something magical that people can do now with their phone that they couldn't do before. I think that's the space I want to be in. And hopefully the game is a success, but if not, if the game doesn't resonate or we aren't able to turn this into something, I think I've learned a lot about GL acceleration and things that you can do with the phone that haven't been done before. Actually, to give you a sense, so this is the version before we Yeah, there we go. This one. Yeah, this is the version before we rewrote it completely. So we've still got a lot of the common features, but this is about 10 frames per second video as opposed to 30 frames per second video. The graphics aren't good. We don't have anti-aliasing in the graphics. There's a lot more things you can do. This is all using native Android drawing for just regular 2D drawing objects, and then this is using OpenCV for the collision detection. So it's roughly the same, except that we get a lot more flexibility by doing all the hard work. And actually, Sloop over there did a lot of the work on getting this to work as part of the port. So thank you, Sloop. And let's switch back. Any questions so far on any of this? You want to give them the...
There are lots of games which are also based on augmented realities.
Yeah.
So how different this than the AR approach?
Well, it is sort of AR, but I haven't seen any games where you're playing with the world. You know, there might be, it's a sort of different approach to AR. It is an AR class of things, and I think that AR type of things are a very interesting space to be in. So I'd say it's in that class, but this particular style I haven't seen before. But I mean, the reason I'm doing this is because the phone as an integral part of your life, that's the thing you carry around with you in reality. Makes a lot of sense to be one of the tools for you to help discover more things about the real world.
The 3DS from Nintendo, I think, has one particular game where you can take pictures of your home and then that actually takes you to the game level and then you can have members of the sprites that you mentioned and all that.
Yeah. So you can do, yeah, so.
Yeah, that's the plan. I haven't seen something like this on phone.
But like I said, I like this was a fun way to use the device and things like that, and just sort of looking for. And if people like it, they like it, and if not, it's going to be. I've learned a lot from this, and I think using it to accelerate speech recognition will be a lot more. I'll understand where the strengths and weaknesses of this are. But this was sort of to stretch me to the next level of trying to figure something that I was really a bit scared of learning about OpenGL, because I know it's difficult to debug these shaders, it's difficult to work with them. Do we have a mic?
So my question is with regard to moving computation to the shaders. Is there no library out there which does it, and did you have to do it by hand? I mean,
you really have to do it by hand right now. There's things like OpenCL that give you a bit higher level area to it, and Google has their own completely incompatible thing that does it as well, render script. But right now it's a bit of a black art. OpenCL, they just pulled the support for it on the latest version of Android. That I think Qualcomm had shipped some OpenCL drivers that people were pretty excited about. I was actually pretty sad. I thought, oh, this is great. We're going to have something that's a more higher level interface to this stuff that's going to make it reasonable. And I think there's some CUDA drivers that are going to come out maybe next year. CUDA is another approach to this stuff. So OpenGL shaders are about as ugly as you can get and get into this stuff. Very difficult to debug, very difficult to test this stuff, but not very, but it's sort of like going back to an assembly language almost approach to get this to work. Let me see if I can just show you some code. But it looks a lot like C. I mean, that's the good part is it looks a lot like C. It's just really hard to debug. Of course, on this screen, you're not going to get any. You're not going to actually see anything in. Actually, probably maybe Eclipse refuses to run. At this lower resolution. That would be funny. Okay, here we go. So let me just pull up. I mean, it's kind of it's a cool thing because you can get stuff working. Sorry, on directory really well, but it's just black magic in a certain way as far as. There we go. So. Like this is the stuff. It looks a lot like C, right? This. How do I make this? Come but these are special things that get compiled down into by the shader. Actually, you send the GPU. I'd ask you your program as you start up, and it compiles it down on the fly into a regular program and does the right thing. So but if you're in a C or a Java mindset, it's not hard. It's just a pain in the butt to debug these things, and we actually have to pre-process this in a different way for Mac OS versus Android, and because they're all slightly different versions of the shading language and things like that. So it's not that easy to work with, but it's not crazy either.
So on the Android world, is there a device limitation for this support?
Sorry?
On Android,
yeah.
What kind of devices support this shader?
Pretty much every device supports that. I mean, anything after 2.2 will support it. So that means 98 or 99% of all the devices that are being used right now will support OpenGL computation. And pretty much and this is GL 2.0. Actually, most of them will support GL 1.0, but these kind of shaders came out in OpenGL ES 2.0. And iOS, pretty much all the devices out there support it too. It's just people don't take advantage of it because it's perceived as a pain in the butt, which it really is actually. But
Apple has come up with a GL kit which helps us do it a bit easier than writing all that C code.
Yeah, and then the problem is that it's hard to do device-independent stuff if you have one solution for Android and one solution for iOS and one solution for Mac, and so GL shaders ends up being the lowest common denominator that works on everything. Just like C and C++ are the lowest common denominator that work on everything, and so in the interest of making stuff happen, I've ended up working with these low-level kind of semi-difficult versions of stuff. But
yeah, hi. So really interested in knowing the GPU part coming onto our handheld devices. So can you give a little bit of maybe a head start or maybe a couple of pointers where we can start a Hello World in GPU or something like that?
yeah, there's some good books. I'd say if you go through some tutorials online, you can get a lot of it. The problem is, it is hard to get started on this. There's not there's not a lot of Stack Overflow questions answering your questions about this stuff. It ends up you having to sit there and stare at it and try to figure out your own ways to debug it and get it to work. And because I learned how to program in an era before there was Stack Overflow or even a lot of documentation sometimes for things, you learn to try to do that. And it's a good skill to have. Otherwise, you're limited to the kind of programming that can be easily answered on Stack Overflow. So it's sort of if you're willing to confine your life to integrating Facebook and making scrolling lists faster and things like that, then you're going to be fine. But if you want, like I said, I realized I wanted to stretch myself and do something I hadn't done before. So you get into something that's hard and difficult to debug and where you have to think about it, and you inevitably are going to learn something. Okay, which gets into my last section, which is just about innovation. And I think that one of the common common discussions about the difference between America and India is just why is America innovative? Why is it hard to innovate inside India? You see this even in pop culture like Three Idiots and things like that, right? Is people are, why is there a focus on memorization and following the rules in one culture, and people seem to be much more willing to break the rules and make stuff happen in the other culture? And it's a simplification, of course, because that's what media does and things like that. But there is some truth in that. As far as you've got a tremendously large country with some of the most brilliant mathematicians in history coming out of it. But why isn't India outsourcing to America? Well, it is starting to actually. A lot of call centers now. Tata has some call centers in America to handle situations where they have clients who want that. But in general, why is it going this way? And I think this American startup culture where when I started at Dropbox, it was 18 people. We had already at that point 3 or 4 million users, this ability to leverage a very small team to build something very big, I think is something that's unique to this period of time, but I think that's one of the things that America has, sort of, Silicon Valley in particular has figured out how to do. I think the question is, can you ever get something like a Leonardo da Vinci painting if you hire 100 painters or 1,000 painters or 1,000,000 painters? You probably aren't going to get to that no matter how many painters you hire. Just because it's not a problem of scale, it's a problem of intensity and focus and willingness to try to keep learning and things like that. So say that's if you want this innovation and finding, and sometimes actually with a group of 3 people, because Java, the way Java got started was they got basically 4 of the top people from Sun together and said, okay, we're going to go and get our own office. We're going to go and hide in this place and work single-mindedly on this for a year or 2 and see what happens. And you got Java out of that. Of course, after Java became successful, then it sort of, that original core Java was actually quite beautiful. Then, it didn't do a lot necessarily, but then sort of standards committees came in and said, we're going to do dates in this incredibly Byzantine, horrible way. We're going to go and create all these weird object serialization formats, and we're going to create these RPC layers. And suddenly you get this very Byzantine thing because you lost that focus. You ended up thinking that hundreds of people are naturally going to come up with a solution that's better than one that a couple people could come up with. And so I think there's somebody who said this fascination at, you read the blogs and you see this people saying that we want the 10x people, the people who are 10 times more productive than the regular developers. And it's not just the 10x people. It's, like I said, it's that some people just can build a multi-threaded transaction system, and some people can't. And regardless of how long they spend on it, there's going to be subtle timing bugs. There's going to be subtle other bugs, right? And some people can get this and think hard about it and figure out the right way to handle all the subtle interlocks and things like that and get it to work. I don't think it's necessarily a raw talent thing. I think there's some part with it. Some of it's just learning to question everything and learning to rise to the occasion, figure there must be a solution to this. I'm going to dig at it and figure it out until I can, rather than thinking, okay, I've got this 90%, let's move on to the next problem and hope that the end result is not going to have too many bugs. That was another thing learning from Dropbox is people were really willing to spend a month trying to figure out a solution to a very subtle timing bug that was only affecting a few customers, but was nevertheless destabilizing to the app as a whole, to the product as a whole. Not talking about just I'm talking about the server side and things like that. Because if you get a small destabilizing part of it, often it can propagate through the code. You end up with some metadata being corrupted. Eventually, that's going to mess other things. And that focus on the discipline of making the product awesome and really beautiful also pays off because the other parts of it start to do that. And the best way I've always found for doing that kind of code is just constantly refactoring what you're doing. There's always revisiting the code you wrote, rewriting it, remaking it until it's really doing the right thing. Go into code that I don't understand a week or 2 later, then there's a problem. And you have to go through and figure out what's going on there. Because often if you can't understand it, there's a problem. Even if you sort of felt like you understood at the time you wrote it, there's a good chance that you were misguided, and so keep getting stuff simpler until it's just intuitively understandable, the code that you've written. And then you get into things like lean startups. And I love this quote: "A startup is an organization formed to search for a repeatable and scalable business model." It's not about trying to build something. It's not about trying to make anything big. It's just trying to find something that has the core of that business that can become big. As soon as you've got that, build out your system build out your product people, build out your marketing people, but until then, all that's just dead weight. Because you don't know what you're building, you don't know what people are going to like or anything like that. And keep going. You want to change something, have an idea, test it. Have an idea, test it. Keep going in a circle where you're refining stuff. You have a hypothesis that you can test. People are going to use this file sharing feature or not. People don't use it. Either then you test to see, well, maybe we didn't make it visible enough, or maybe we find people don't even care about it. But keep this as a tight loop. user forums and things like that are awesome if you can get people that engage in your product. And sometimes just going and buying a few Google AdWords and seeing if people even care about this as a product is, you can spend $100 on that and find out that nobody even cares enough to Google for it. And that's way cheaper than building a product and trying to ship it. And people often are very quick to say, okay, oh, that didn't work, let's pivot to something else, let's pivot to something else. It's, it's like Color. There's a company, Color. I don't know how many of you guys follow that here, but they got something $40 million in funding, and they were trying to recruit me away from Dropbox. I went in and go talk to them, and they were pivoting like every week or two. They'd go and the developers would go and kill themselves, and they'd get really good OpenGL quality rendering of all their stuff in Android to make it performant. They wrote their own maps APIs. They were doing all this stuff. 2 weeks later, they change their mind again and do something else. And the developers are like bravely talking about how great work they're doing, but in reality, they're just spinning their wheels constantly, killing themselves over and over again to make something that's going to be thrown out in a week or two. So, be careful about that too. As far as what we've been doing, it's a bit of an experiment, which is to have a small core of the company that's in San Francisco. It's basically me and a couple other developers I talk to and contribute in their ways. Been working with Satendra Singh over there, who's been managing the project, and Asloop, who got some great stuff done. We've had some other developers too, but Asloop is good enough that he's starting a master's program in the US in the fall. And so I'm really looking to rebuild this group. And I'll get into that in a second. And then we have art direction in Poland, and some the music developments being done in Providence. And so it's a distributed team, but really looking to have something that works as a company still. And we're trying to really build this good. And not just programmers, but people who can make stuff. I want us to think of people, oh, you're a coder or whatever. But you're good at making things that people use. And any of these skills, looking for people who can work in a couple different areas at the same time, because I think that shows that kind of openness to creative thought, kind of openness to things. And because I do believe in India, and that there's even if the educational system has messed up some people, I think that that this ability to be creative and to come up with good things is universal for human experience. So if you guys are here, anybody wants to talk to me about this, I'm not sure exactly the right way to pitch it, because I know that in India people really prize working for a prestigious company. But you get a chance to work really closely with an American who's done some startups and has had some success in them. You get a chance to get some insights and connections into ways a startup works, and ways to, and ways that Silicon Valley and all that stuff works. So whatever, if anybody's just interested in exploring that, just let me know. I'm here until I'm leaving Tuesday morning, and I'd love to just sit down and talk with you, even if if you've got that kind of interest in pushing the envelope on what you're capable of doing. Because you're definitely not going to just be building some order inventory system or something like that. We're going to be really pushing it on it. And that's pretty much it. So, ready to take questions?
Lots of application that you have shown, few layers have been written specific to the platform, maybe for Android, maybe for iOS and all. So how do you see future of HTML5 or the platforms like PhoneGap as far as the cross-platform porting of the application is concerned?
Yeah, I think I've spoken a bit to this, but I'll say it again. I think these are really good if you want to do things that are quick and cheap and fast, and the are getting better. But if you want to really, I just know you can't build Instagram in these layers. I don't think you might be able to build Dropbox now, but I think some of the lower, deeper file syncing things might be tough, and the deep level of integration with the OS would probably be tough with these things. I don't think you could build Magic Piano or a fast responsive game with them. But I think for 90% of the utility apps out there, and most of the things that are basically doing better to-do lists and better, things like that, I think it's a great approach. But I haven't been living in that space, so I can't really speak to it.
How do you see future of web sockets, particularly in HTML5?
Like I said, I don't know that much about HTML5. I'm peripherally aware of it, but I've been avoiding that just because I know that I'm going to be pushing things more than what they're capable of. So I'm just sorry I can't really speak too much to that topic because of where I've been. I want to really limit to things I have a lot of experience of. But I think, like I said, you're probably going to get to 90% very quickly with all these things. And for most apps, that's very well going to be good enough. And it's certainly going to be cheaper. What I'm talking about is expensive, time-consuming development that needs really good developers to do. But if you want to get to the top, if you want to have a top-ranked app that's being used by millions of people, if you want to probably add up how much Dropbox spent on their app or how much Twitter has spent on their app, it's going to be a lot more than what these what these other companies are working on, or QuickOffice or any of these. These are massive undertakings that you probably can't do well in HTML5.
You didn't say a single word about Windows Phone.
Yeah. I don't know. I mean, I guess I don't have a lot of faith in it. I'd love to be surprised. I'd love there to be a third platform out there that was really solid. Also, I don't have experience with it, so I'm not going to be able to speak to it. But I think you could take most of what I said about bridging and Objective-C and Java and just substitute them with C#, and you'd probably have a lot of the same. I'm guessing that it would mostly be true, which is that you want to avoid writing in these platform-specific languages if you can help it, and rather bridge into C or C++, or go into Lua on top of all these things. But I think focusing on, I guess you can write your stuff in Mono or something and take the C# and cross-compile to everything. Like there's a lot of different ways to do it, but I haven't used them.
And what about the new Windows 8 RT tablets?
Yeah, that's another thing I haven't spent much time on. And
so like when you say Android gets slow at times using Java, and so maybe .NET has better performance issues?
I think whenever you have a interpreted language, JavaScript is, C# and JavaScript are roughly the same language. There's not a lot of difference between, they use different syntax, but they're in the same niche, right? And there's only so much you can do with that type of language as far as optimizing it and getting real-time performance in and out. And the same thing with JavaScript. There's a different layer that you can get roughly the same kind of performance, but just by the factor of having garbage collection and having reflectivity and having some sort of dynamism and things like that, you just have some overhead that makes it so it's just hard to do the kinds of stuff you can do with C and C++. And you can make it come within a factor of magnitude, but you're also going to need a lot more memory for caching things and figuring things out. It's just hard to get that pedal to the metal performance with bytecode type language. And like the PyPy people have done a good job with that too, but it's just faster than Python. It's not yet coming close to C level. Any other questions? Okay. Well, thank you all for coming.
Yeah. So.
Did you? Sorry.
So it's not a question, but like, see, most of the time I think about taking an approach of should I just use a ready-made library or utility which someone has written, or I should just do it myself. Yeah. Sometimes it's roughly the same. I need to explore what that guy has done, understand the APIs, and then I can build it also roughly in the same time. Yeah. But what's the general thing? Because most of the time you talked about creating out your own, even in Dropbox or things like that.
Well, Dropbox, that was probably because a lot of the stuff, I probably might have built it on top of stuff that's available now. But I didn't build it, but it wasn't around then. This is 3 years ago now, which is a long time in this world. The other question is often you've got a choice of a lot of libraries. Like if you had to do Unicode transcoding or something like that, the default libraries, every time you add Unicode support, you're going to have about 2.5 megs more of app load right off the top, right? So, or more or less, or maybe you can get by with a quick thing that doesn't handle Unicode fully, but does the right thing most of the time. And so those are it's a different. I'd say the ability to make your own when you have to is because if you can't, it's like if I was an artist and I couldn't draw really well, right? But I was good at copying things, right? But but I mean, it's like sometimes having that deep knowledge of your craft, so you know that you can build it if you have to, lets you make that decision more effectively instead of just saying, oh, it's which of these 12 libraries are we going to use? Or sometimes it's also you can't pick between them without knowing what's happening in the lower layer. Someone said, I was reading recently, says until you write your own compiler, you're not a real programmer because you are used to just everything being magic. And it's at one point when you write your own compiler, you like start seeing how everything gets turned into byte codes and into executable operations and things like that. And then you have a better sense for what's going on in and out of your system. And so then you can start making optimization choices more effectively. But yeah, I would 99% of the time I'll use something off the shelf, because there's no point in writing your own JSON parsing library.
And Tom, there is a...
Oh, thank you.
So, yeah, thanks for coming. And same thing which I say every time, we are looking for speakers. If you guys want to talk on some technical subject, send me a note. Use the meetup interface and contact the organizers, and we'll get something set up. Okay? Thank you. Yeah, so